Okay. What are we doing tonight? Account for tile traversal cost, map, tile cost, firing radius. Yeah, movement. Okay, right. Burn down check. Okay. So, okay. So what were we doing? We had a radius had a cells property, which is actually a set of cells in the movement radius, and we need to compute the firing radius at the edges of those guys. So let's see. Wait a minute, why is that 3? How did we get to a literal... We had a literal 3, how did we get to 5? Okay, this is still not correct. Interesting, it takes a lot longer as that number goes up. I mean, it's obvious why. It's a linear, and it's probably not even, it's probably worse than linear time, I guess, but I'm surprised it's that noticeable. Okay. I guess that was an easy fix. I just had forgot to remove that constant, so fine, whatever. And then some of the math was off by 2 or something. Okay, whatever. Small diversion. And I guess from a game design standpoint, what we've learned is we want to pretty much cap... Well, oh shit, this might get worse, actually. We want to cap... So by the time we're trying to compute a radius of 8, see, that's fast, and that's very slow to work that out. So maybe we can optimize something there that's possible, but if not, even 7 is kind of laggy. Six is fine, so that would mean, you know, we got to be mindful to keep the combined radiuses within that limit, so we don't have that snag. I'm wondering what the I wonder if we can optimize this at all. I wonder if just getting rid of this, if we can kind of inline this function, maybe that would help. See if that did anything for us. Oh no. Guess we inline this. See something. This, I think I need to vivify that. This should crash. Yeah, okay. I bet you this is expensive, because I made a note before that that is a linear time operation. So... yeah, this will probably be better. Let's see. Did I not put you back? Better, but still bad. Yeah. Hmm. Hmm. What I've read is that looking up globals in Lua are slow, so I'm trying to get those lookups out of the loop. Yeah, okay. I mean, that's certainly better. I don't think it's adequate, though. I wonder if this construct is any faster. What is the normal loop syntax? I don't remember. I need to... Can I do that? No. Just out of the sake of curiosity, let's see what happens if we drop back down to 30 frames per second. It's still perceptible. I don't know if fewer interrupts or something would matter, but it doesn't seem to. It's still very noticeable. And this is in the corner, so presumably this gets worse in the open. Hmm. So that's not great. Because we do need to make this check also. We can make that more efficient, but we do need to do it. And in fact, we need to make another check too. It takes about a second to compute all that. Well, I think maybe this means we do need to find an alternative to recursion here. Kind of in line with my original instincts, because, I mean, like, we could work around this limitation in game design by saying your maximum speed plus firing radius is you know, 3 plus 3 is 6 or something, but that's shitty. I mean, that would make it would ruin the game. So that sucks, because I thought we had this figured out last night, but this just isn't going to cut it. Yeah, okay. Oh, hey, Subvertus. So, remember last night we worked this out, or we thought we did. What I've realized, though, is that this performs pretty poorly. So, like, if we move our guy somewhere, and I'm intentionally in the middle of the field here, so I clicked on the guy, and, you know, you couldn't see it, but there was about a 1 second delay while between me selecting this unit and then the rendering of the movement radius. So that's just not going to cut it, because the other thing we still need to do too is take this and append to the end of the movement radius an attack radius, right? And you know, I was saying a second ago, we could hack around this with game design by just making sure that those numbers are small. Your maximum movement and your maximum firing range must be less than 6 or something. But I mean, that's just shitty, right? That would ruin the game. So what I think we're looking at probably having to do is refactoring our recursive algorithm to be iterative instead, which I think will run faster. I don't actually know that, but I also can't really adequately profile this and pick a weight, so I'm kind of just gonna go for it. But yeah, I mean, like if you just watch, watch the little indicator up there. Like I'm click. And there. I mean, it's about a second. So yeah, we got to do something about that. So anyway, that's the problem. Gonna try to refactor this recursive guy to be iterative, because I already, I don't know how long you've been here. I already refactored a little bit here to just try to optimize the recursive thing, and I made a little progress, but it's not going to be enough, because I'm pretty sure this thing is on geometric time or something. So like if we go, like we're at, that was movement speed 8. If we set that to 9, it's going to get even worse. Go to the middle. So like here, so I'll click 1, 2, 3, 4, 5. Did that even go? 1, 2, 3, 4, 5, 6, 7. That didn't. Oh, I have to run that. Let's go from 8 to 10. This might even blow up the game. Yeah, now this guy, like, this is soft lock now. I mean, click. So what was that, 10 seconds or something? Like, not gonna do it. So that sucks. So now I got the old Stack Overflow. Right out how many recursions we're doing. Yeah. I think it would just be the number of cells that we have, right? So I think that's correct. But anyway, I think it's one of those, you know, geometrically scaling kind of things, because each time the radius increases by 1, yeah, I don't know. But anyway, I think we just got to kill this recursion. So I have just a refactoring thread pulled up here on Stack Overflow. And I think we want a pattern something like this. This kind of makes sense at a glance. So I guess let's stash this and start a new branch and just see where it goes, because if we can't make this work, that's like a threat to the game. It's like a major problem. Like we'd have to come up with some entirely new way of managing movement and stuff. So, let's see. Yeah, I think let's keep our refactoring just to this radius thing. And let's set these guys to 8. Because that's where the problems start to become really evident. Reload. So we can see that was really bad performance even in a corner. Let me do this too. Let me just comment out map 1. Map 2 is better for testing, and I don't have to advance the stage all the time. This has to be the best song on the Commodore 64, this Outrun theme. I love this song. Okay. So what? We're on a track. Cells. So we want to add the first cell and start with that, and then loop over these cells. Maybe this? So we have our collector or aggregator or stack or whatever of cells. And we start on cell 1, iterating over every cell in our collector, and if the number of passes through the loop is greater than our movement speed, break out of the loop. Identify the cell that we want to read. If that cell is passable, blah blah blah. Append it to the radius cells group. And then add it to the collector, and then increment our loop, maybe? Let's see. I'd be shocked if I got it, but yeah. Is Lua case sensitive? Cells. Line 18. Stupid, but it's the easiest way to figure out what's going on. Also, we don't need any of this. And I'll probably end up inlining. Wait, I'm not. Where am I checking? I'm not checking near anywhere. I fucked this up. So this is still gonna fail, probably crash, yes. Oh, and I'm not, I need to... I need to pop this thing off the stack. Because we're just going out of bounds here. I think we just work like this in Lua, I think. It's just cells I equals nil. I think that's not a pop, it's a delete, but that's fine. Make sure I'm not being too clever here. Okay, we don't crash anymore, so that fixed up that one problem. Now the other problem is we aren't doing the near thing. Let's go ahead and just inline this now. This won't unit test as cleanly, but I think it's pretty clear that this is a hot code path, and we just need to do this the kind of ugly way for performance sake. Right? Oh, except now it's this cell. So we get the current cell. If that cell is passable, we append it to our collection of cells, and then we add its 4 neighboring cells, and then we unset that cell. I don't know if this is going to do what I want it to do, I don't know, we'll just run this. What's in the cells table? What I want to be in the cells table are the XY coordinates of cells that we have identified as movement candidates. You know, the cells that compose the movement radius. That's what I want to be in there. Whether I've succeeded at that yet, I'm not sure. And it's hard to find out because, like again, kind of a recurring problem is that I'm not aware, at least, of any good debugging mechanisms in Pick-away. If I could just, you know, var dump that thing or something somewhere, that would be convenient, but I don't think I can. This isn't the problem. I'm gonna go ahead and inline this now too, because we're gonna have to get there. I wonder if there's something weird going on here, because I feel like we're in the right ballpark now. I'm wondering if we're creating like a nil space in the middle of our table and it's forking the iterator. Let's see. Let me put that back. Okay, see, that did something. Cells I. Oh, I guess doing that. Okay, this is another case of cell is just a shallow copy of cells I suppose. So if I delete that there, these become undefined here, cell becomes undefined there. Okay. Well, I think I found we have an assert. Here, let's abuse that assert thing I found. Yeah, okay. So we can abuse this assert as a debugger, because the way assert works is you pass a condition, and if it evaluates to false, it throws an error message. We can just set false, make it fail, and then we can kind of use this as a debugger. So by the time we got here, what did we have? Movement. That's correct. Yeah, movement's gonna be how far the unit can go. We didn't even make it here. Okay, well. Why do you not think you're passable? Wait, you wouldn't be passable because that's where the unit is. Let me. This is fucked up. Let me knock this thing out. No, sell. That's always going to fail because that's where we are standing currently. So let's take that out. Now we should crash and see 1 again. Good. Now we should crash and see 4. 5. We should see 5. And movement is how far we can go, and it's also effectively the radius of our thing. Okay, we see 5. And then we want to see 4. Slip 5. Is that correct? That doesn't seem like it should be correct. Five. So it's not actually... That doesn't actually pull it out of the table. How do you pop in Lua? I thought nil would do it. With cells, I don't want to strictly delete the last element. I want to delete the one that we just iterated over, because you know what we're doing is this is supposed to be like a collection of cells that we have yet to inspect, and by the time we're here, we're finished with that one. So you know, this is a stack, right? This is a stack of cells that we need to inspect, and here I'm trying to remove this from the stack. And I'm probably just making a mundane error here, and don't know how to do that in Lua. I thought it was nil. See, there's a standard library function that does this, but we don't have access to the standard library in Pick08. Here's a library for Pick08. All right, let's take a look at that. Appreciate it. Yeah, okay. They do have a pop. So what are they doing? Okay, I appreciate it, Tiberius. This is definitely what we're looking to do. Just organizing my tabs over here. I have a bunch of crap open. So, okay. So I have your library open on this other monitor here. Well, here, I'll bring this over so you can see it too. Delete value V from table T. we might be looking for unshift, because this is a first in, first out stack we have here. So what we want is that first element just to go away. Let's go, Noctis. Good to see you. We made a discovery at the start of the stream tonight, and it was that the recursive radius drawing algorithm we wrote last night is just not performant enough to be feasible, unfortunately. What we discovered is that when you increase the movement radius out to like 8, even after I'd optimized it, there's about a 1 second delay from when you press the button to when you get a radius. And if you set that to 10, if you set the radius to like 10, then it takes like 10 or 15 seconds or something. So what we're doing is we've been refactoring that recursive algorithm to be iterative, and I think yeah, I was a little worried that the recursion was going to be slow, but I'm surprised at just how slow it was. So yeah, so we're refactoring out. I feel like we're pretty close, but I think I'm failing to do a mundane Lua thing here. I'm a little surprised. Actually, wait, maybe I just want... I think that might have been the problem. I always want this to be 1, right? Yeah, that's the thing. If we're working in anything but pick await, it probably wouldn't be a problem. But yeah, pick await wasn't having it, unfortunately. So the refactoring now is we're implementing our own stack of cells to inspect, to see if they're within the radius. And then we are iterating over that stack continually, unless we hit our movement limit. Non-recursive. Yeah, I think this is very, very similar to what we're doing now. And as dumb as it is, I think the only thing I'm failing to do is popping or unshifting, I guess, this element. I'm surprised these people are popping. It should be an unshift, right? At least in ours, it's an unshift because... Yeah, I think for us, we always want to delete the first element in our stack. I think. Unless I have this screwed up in my head, we're removing from the front because I'm initializing our aggregator with the XY coordinates of the specified unit. Or, well, yeah, of the specified unit. So that's the first cell that we would check. We would find its neighbors and crap. Yeah, we would shift it. What I'm trying to do is this, because cells 1 would always be the first. But I think this is just like punching a hole in an array in a way I don't think this is actually unshifting. I think we probably have an array that just has cells 1 equals nil and then cells 2 is another point or something, you know what I mean? Saberdis a moment ago linked this, which looks like an excellent library of pick-away helpers, and I think this is probably pretty close to what we want to do. I was just trying to see if there's a simpler and or faster way to do this, because this is I think this is going to be a hot code path. I think you can iterate from end and use pop. It's just backwards but the same. Can I though? Because I'm adding the cells here. So, you know, on one pass through the loop, cells 1 would be the position of our unit, and then elements 2 through 5 would be the neighbors of that, and then we need to unshift cells 1 because that's where we started. Oh, okay. Yeah, okay. I think I see what you're saying. But yeah, I think it's just this that's failing. What is that one, the number cells 1 minus 1 do? What I don't think I've seen the loop with 3 parameters before. Is that like a step and a what is that? That starts at the end of the array and moves toward the front. Oh. Okay, so parameter 3 is just a step value or something? Is that what's happening there? The -1, is that a step value? So like that just says subtract 1 every pass through the loop? Because I didn't actually know you could use that kind of syntax in Lua. Okay, interesting. I might refactor into that in a second here. So yeah, I think we just got to solve this mundane problem, and then I think we'll be there. Yeah, okay. Yes, Robertus, I'm going to try your thing. Table remove is an unshift, but Pico doesn't support, so a helper's going to be a little slow. Yeah, that's the thing. So I don't know if you saw this, but this is what Robertus linked, and this is definitely the right idea. I was just trying to see if there's a faster way to do this, because I think this is probably going to be like the most performance sensitive part of the whole game. I think. So I would like to make this as efficient as we can. See, the Lua, or the Pico 8 API has a del, but I don't think this actually compacts the table. And this is like, yeah, I mean, this is totally wrong. That's like a searches for a value and removes it. That's not at all what we want. What's this del I? Wait. Well, check this out. This is weird. Del I. There's a link to that from the bottom of the del page, but this isn't actually listed in the top of the... This is actually listed on the API page. I'll see if I can change that, because I think this is exactly what we need. I think. So del just finds the first matching element by value, I think, right? Where I think this del I guy actually... I mean, I guess this is always a 1. Let's see what this does real quick. Check out that del I, though, Noctis. I think that's probably a more efficient way to do the same thing, and it looks like it did. I think it got rid of our... Oh, I have my assert in here still. Let's see if that works. We don't crash. No. Oh, but now we have... This is wrong. This should always be 1. Yeah, del I is the same, I think. But by index, and that's what we want here, I think, because we always want... We want to unshift. We want to remove the first element always. So I think del I sells 1 does what we want. And then local sell will always be 1 because we want, again, the next guy in the... Yeah, the next guy in the stack. Just curious. This is a little... Yeah, exactly, Noctis, exactly. And here's a stupid little hack I have begun doing. I found out that there's an assert in... I don't know if it's Lua or Pick-a-Wait or both or what, but I'm using this to debug now. We just manually fail an assertion, and then we can write some output to our display here. So, okay, yeah, so here... So by the time we're here, we have a length of 4. We have 4 cells in our stack. That's what we want to see. Well, this is surely, again, a dumb way to do this, but I don't know if there is a smarter way to do it. Say you iterate 5 times with a table grow exponentially. I don't know if it's exponential, but it's probably geometric or something, right? It would be like 4x every time, I think. Something like that. Yeah. But yeah, it was definitely growing to be unmanageably large recursively. I'm hoping this clears it up. I don't understand the behavior we're seeing now, though. Wait, yeah, I do. No, I don't. I don't understand why we're only getting that starting cell. Cells 1 only each iteration. That's correct, isn't it? Because I think del I compacts the array, or the, well, yeah, let's say the array again, such that cells I is always... I mean, I thought that's what it was doing. The del I function moves the value at the given index. All subsequent values shift down by 1 slot to keep it contiguous. Cells need to be outside the while loop. It is, right? We're initializing it there. And I think cells 1 is correct because del I removes the element and then shifts everything down. So cells I should always be the first element, like the bottom element in the stack. Or the top. Yeah. Actually, what I am doing is maybe goofy, though. Let's see. I don't know. What's movement being passed? Oh, actually, it would be... It's not 2. It should be 8. Here, let's just debug that. We make it past this. Let's see what... Let's just debug this. Yeah, so movement is 8. What if the brake is breaking it again? Same behavior. 14, yeah, same behavior with the return there. Kind of weird. I really wish there was a way to just like, if we just, you know, dump values to a console or something to make this dramatically easier. Invert it to I think that's the opposite of what we want though, right? Because here we want to exit if and only if we have made more loops through cells. Like if the number of loops we've made exceeds the movement, right? I think this is different. I remember what you're saying, but well, here, I mean, this is yesterday's logic. Well, okay, here. What if I just comment this out? What happens? Unbounded recursion or something? It's getting pretty pissed at me here. See, this can't be right. So the game is now locked up. Out of memory. So actually that might have been right because there are no impassable tiles on this map. Let's actually put map 1 back in and see what it does. I mean, this is like, that's not the fix, obviously. It's just let recursion run endlessly, but this might give us diagnostic values. So now we're pegging our CPU again. How the add function is looking, let me take a look at that in a second. I think we're about to run out of memory again. Check at the end of the code block. Okay. Okay, there we go. Run out of memory again. I'll put it there too, just don't forget. so now we were back to... Yeah, like this, right? With the break, just after runs. And Severus, what were you asking about the add function? Yeah, we're back to square one here. I don't understand why we aren't getting anything done here. Let's see. It is adding the cells. So after, we're gonna hit this assert. And we can see here we have, wait, 4. That should be, no, 4 is correct. So yeah, after our delete we have 4. Before the delete we have 5. So the cells are being added. Can you check cells length in print? Oh yeah, I just, yeah, that's what we did. Wait, am I doing, maybe I'm doing something stupid here. Let's take a close look at this. We're setting X to cell.x plus 1 and Y to cell.y. Cell x minus 1, y is y, x is x, x is x, y plus 1. See, that looks right to me. And we're setting that cells here. This is just our stack of cells to explore. It's not the radiuses. What are we doing with the cells? Do they need to be appended? So, again, for the sake of performance, I just inlined this append function. And that is inlined here. And again, all I'm doing is creating a nested lookup table of XY coordinates because I want radius contains to be a constant time operation here because we're gonna need to check if our unit or well, I guess if our cursor is in one of 2 radii, right? So that needs to be fast. So that's why I did it that way. But we are doing that. So it's confusing in that we have 2 different collections of cells. One is the collector for our iterative function here, and then the other are cells that are confirmed to be within the radius. But I think that is correct. I'm actually pretty confused. I don't know why this isn't working. It kind of seems like it should be. Yeah, when I print the cell's length here, it did in fact grow. I wonder if this is failing. Yeah, this did grow. The failure we're seeing would make sense if this were failing. Let me put this back. Like, I don't Did we do something weird with... Did, like, self change its value somehow or something weird? Oh, wait. Okay, hang on. Self doesn't mean what we think it means or something here. How did... What's this? What's going on here? Something's screwed up, because... Like, we'd expect to see something... 20 and 21... I don't think that's what I'm doing. So what I'm doing is vivifying self.cells x and then setting self-cells xy to true, because if I just did this, this would fail because cells x doesn't exist, right? Well, I say that. Oh wait, hang on. Attempt an X field question mark a nil value. Yeah, so I think this is correct. Though, I mean, with that said, like, it seems not to be, because this is pretty confusing though, like, if you understand correctly, in the first loop, you add 4 elements to the cells, remove 1, and increment I. You'll have more than 8 cells, but only iterate through 8. We should iterate through everything, because line 13 is saying while the length of the cells table is greater than 0, continue to iterate. So we shouldn't exit this loop until we're finished. But again, something isn't working. And specifically, something is not. But you break the loop if I is greater than 8. Oh. We break the loop if I is greater than 8. Just gonna OOM again, probably. You only get 8 cells. Maybe you're right. You probably are right, actually. They are independent, but that might be the problem, because that logic only makes sense recursively, right? I think Suburgis is probably right here, because I bet you this weird thing we're seeing, I bet you if we count these cells, we're going to see we have 8 of them. 1, 2, 3, 4, 5, 6, 7. But we started on 1, so... Is that right? I'm not sure exactly what's happening, but I feel like Suburgis is on the right track here. Alright. I think this is... Yeah, look, actually this is exactly the mistake we made yesterday. That should be inside of here, right? We don't want to... I is... Yeah, okay, sure. I is 100. I think I see it, though. Let's set that to, like, 25. See, this wants to... I think you're exactly right, Sibertus. This isn't being allowed to trace this all out, and it's because we made basically the same fuck up from yesterday, or I did. You guys didn't do anything wrong. This should be here, because this is... Phi is less than. Because we don't want to fail... We don't want to exit the loop prematurely. We just want to stop adding cells to the stack, I think. Something like that. What's that going to do? Oh, yeah, Saber with the huge brain here. Still looks kind of wonky. It's removing one each time. After the first, it adds 4. Yeah. Are you saying just take this out entirely, the del I? Let's see what it does. Okay, that OOM'd on us. So that just looped forever, I guess. Just want to see what this does. I'm just curious what number we're landing on. We landed on 34. What does that number mean? I'm just curious too. Let's put this back and see what that does. I don't know why that is broken. That's interesting and kind of alarming because it seems like it should work. If not, self.cells x. Oh, I see. This is a stupid... This is our lack of compiler biting us in the ass again. There's x and y aren't values. That should be cell.x and cell.y. That's all that is, I think. Yeah, okay, fine. Yeah, that's intentional. So again, all I'm doing here is I'm vivifying the table at self.cellsx, because this is a two-dimensional table that just maps to a bool, right? If these keys are set. And again, the reason I'm doing that is because I want radius contains to be constant time, just so we have really fast lookups. I think that would be a different thing, right? I don't even know if you can do that, because each cell looks like this. Each cell is a table of its own accord with an X and a Y property. So that would be using a table as a key in a table. And I don't know if that's a thing. Maybe it is. Self.cells I. Are you talking about for this bit or somewhere else, Noctis? Severus, one thing you'd try is check the distance of the current cell from the player. If it's greater than movement, then exit the loop. So what I'm doing is, see, it's not actually that simple. It's not about a radius, because let's go back to map 1 real quick. So let's pretend that, you know, my guy is here, and there's a red guy here, and my movement range is 10 or something. I still should be blocked by the presence of this red guy, though. So if we were doing like distance between my guy to cursor, that doesn't get it. You know what I mean, Subertus? It seems like you had an epiphany, Noctis. What did you figure out? Oh, but Subertus, so what I'm just to finish that discussion, what I'm getting at is, so what I am doing is we're using this function to determine if a cell is passable, and if and only if the cell is passable, we check its neighbors, right? So that way we're able to map out every cell that is within the set that comprises the radius. And then we have a contains method here, which returns true if and only if a specified coordinate pair is among that set of cells that comprise the radius. And then we're checking this in our cursor here, where we're allowing the player to place his unit. The self.cells are pointing to the indexes, but the true overwrites the table of positions X, Y. Yeah, so we have like two different cells variables, which is kind of confusing. This cells is just our local cells here in our update method, but the one we're actually interested in when we do the check later is self.cells X and Y you know, it's this guy up here directly attached to radius. So this cells is just a stack that we use and discard when we're aggregating those cells that do comprise the radius. When you said self.cells, you're getting rid of the x and y values. We're not... Yeah, so we're not actually getting rid of the values, though, because those values become the keys in that two-dimensional array, right? That two-dimensional table. And that's what I'm getting at here. The reason I did it that way is so I specifically can make this exact check in radius.lua, or yeah, same file, on line 83 here. Because this will always happen in constant time. Like, no matter how many, if we have 1,000 cells in a radius, you know, this look will take only trivially, if at all, longer than if we had 5 cells in the radius. Whereas if we had... If we were structuring this in this same way, when I needed to check to see if a cell was inside of that radius, I would have to loop over every cell. So that'd be a linear time function that would start to perform poorly as we scaled up our movement number. You know what I mean? Does that make sense? And I'm pretty sure that works, because that's exactly what we had yesterday, and what we had yesterday worked. It just performed poorly. But the contains function performed fine. That wasn't the problem. It's really just how we were mapping out, you know, how we were finding cells that were in our radius. Yeah, it's weird looking for sure. It's weird looking. I think it's the right data structure for this, though. Just because, again, that's going to perform really, really well. But it is weird looking. I'll certainly give you that. I still understand, though, like, I think this check is probably in the wrong place. This is it. This is wrong. This is wrong. Look what I did. This is very wrong. And the original, which again did work, it was just slow. We're checking to see if a cell is passable. No, sorry, we're finding all of the nearby cells, and then we're iterating over those and checking to see if they're passable. Here I'm checking out here. I'm checking the wrong cell, and then I'm just haphazardly adding every cell. This is just fucked up. And it happened because I tried to be clever again. Yeah, that's what's going wrong here. So, like, I don't know where this goes, but we want something like this. I was trying to avoid the loop, but the loop is not negotiable here. We want something like local near. Something like this. And these are the these are the neighbors of the cell that we're on, and then we want to loop over these guys. We're doing something like this. And then for each nearby cell, if it's passable, where does that go? Sure hope this is actually better when we get it working. Be depressing otherwise. Let's see what that's going to do. Okay, immediately that looks promising. So let's go back to map 2. And let's see, okay, that value is at 8, so this would have blown up our machine before. That's not radius 8. Yeah, though that was only like 5. I'm not sure if I'm passing in the right value or something. Make sure I'm not doing a stupid thing somewhere. Unit.stat.speed. Did I just click on the wrong guy? Maybe I clicked on the wrong guy. Eight. Why is it 4? Map 2. Something is still not correct. You can see how we shouldn't have this. That shape is still wrong. I think we're close though. Somehow we're still breaking out of our loop too early. You think I is less than equal to movement is incorrect. If I... should it just be a less than? Sort of funny shape. What about Delhi? Noctis, what do you think is, you think this is in the wrong spot or something now? Let's see. Comment it out. I think we're blowing up. Yeah, that OOM'd. Yeah, it did crash on us. But interesting. Okay. We must be exiting too early. Try check if the cell's distance from the player is less than movement. I don't think that's what we need to do here. Because again, it's not about like a radius. If you know what I mean, like we can't just check if, you know, the distance between the cursor and the unit is X number of tiles or something, because there might be like a river or something in between where the cursor is and where the unit is. That would, even if you're technically still within range, your movement range, that distance is impassable. You know what I mean? So we're trying just to like map the edges of this space to make it kind of fill the shape available, but it's not. But we're doing it wrong. And I what must be happening, almost assuredly, right, is that we're somehow exiting this loop too early. Not the cursor, but the cell you're adding to the cells. I kind of get what you're going at, but I think I don't feel like that's correct. I think that would be like a rewrite of the entire algorithm, wouldn't it? I think it would be, because the recursive thing we had worked. So I mean, I think we fundamentally have the right idea. It's just we need to optimize the performance. I think we just need to identify where we're exiting early, probably, or something. Because somehow, like, you can tell something is interrupting this, right? Like, there's nothing about what we've programmed that should give us two identical columns. So somehow we're looping through this guy, and we're interrupting it before it had time to naturally finish. Is my guess. make it an odd number like 7 or 9. You mean the movement, presumably? It did change shape. It's still lopsided. I might have just noticed something. Yeah. You know what's weird, though? Let's make that 6. Maybe it's not. I was trying to tell if it was somehow treating a radius as a diameter or something, but I think it's actually just screwed up. What if I make it really small? This might just be more wrong than we realized. Yeah, see, something is just wrong, because this is radius 1 now, so this is just wrong. I think this is wrong too. That's like in the wrong spot or something, because we're never actually checking the cell or something. I don't know. Let's go back to our kind of reference implementation here. What's the X position? He starts at 328. Yeah, 328. Do you think that? They got numbers being all 3s for the X. I think that is just an illusion. Change that to 7 or whatever. I don't think that's where the problem is. Self.cells, you think the X val is getting messed up. At a glance, it looks right to me, but let's look at what we had that worked. I think I still just... Yeah, that looks right to me, because it's self.cells X, self.cells Y, XY. I think that's correct. I think I just goofed up the refactoring, is my guess. For each cell that is near our cell, So for each cell that's near this cell, if the cell is passable, append it to the radius. If movement is greater than 1, so there we were counting down. Maybe we're just screwing this up. We're probably just screwing this up. Type it real quick? Okay. Because I think it's here. I think we're doing this wrong. This is maybe we had this right the first time. Well, no. For the hell of it, what's this gonna do? Probably OM again. Yeah. It's gonna OM. I think it's here. I think we're exiting at the wrong moment here. And see, you know, movement was easy to reason about here because it was how much recursive depth should we use, but that's just not the same check we're doing here. Or rather, you know, we copy and pasted that essentially the same code here, but it's just not correct. But it can't be here either. Maybe it's like this. I think it looks like this. Maybe. Wait. It's tricky. No, this can't be right. Sebertus, where... Okay. Let me back out what I did, because that wasn't quite right either. $14 is wrong. Let me try Sebertus thing, and then we'll take a look at. That looks like it's going to OOM too. Yeah. Worth a shot anyway. So think of it as after the first iteration, the neighbors shift to the right each loop. No sweat, Sebertus. I appreciate it anyway. Noctis, you saying line 14 here is wrong, or have I moved it around on you? See, I think you're close to correct. I mean, maybe you are correct. I think the problem definitely has to do with the rate at which we are adding versus the rate at which we're adding to our stack versus draining it. I do think that's the problem, because again, fundamentally we're going to be adding approximately 4 cells. I mean, maybe, not always, but let's say 4 cells per iteration, and then we're popping 1. So I think that's close to where the problem is. I don't know if that exactly is the problem, but I think it's close. I think we just need to stare at this original implementation and see what we've done unfaithful here. because if I is less than 1, I feel like that's gonna OOM, but let's try it. Yeah, I think we're gonna blow up again. I think we just didn't refactor this right. So let's take a close look. So for cell, in near XY, so we have to get our current cell so we can get the near values. So there are the near cells. So for those, we iterate over all of them. If it is passable, actually, wait a minute. I hate this. Hang on. Let me check something. I just realized I've reused the same variable name. Is this shadowing or doing something unknown or unfortunate? Wait, this is probably just add. This is just redundant. Right. Oh, this wouldn't... There'd be no reference for this. What's this do? I still think it's wrong, but... I mean, it's clearly still wrong. But that is an improvement. So Noctis, I don't think it's that, because we don't actually know that we have added 4 cells with every pass through the loop, because the number of cells that we add will be contingent upon whether those cells are passable. You know what I mean? So I don't think it's we do 1 and then we do sets of 4. I think it's going to be more dynamic than that. Does that make sense? I think we have our logic screwed up here, though. Like, again, we have to be exiting too early. That like has to be the problem. Yeah. It's like gotta be this, though. I think we're just doing this in the wrong... Okay, yeah, okay. I think we're just doing this check wrong. Because, see again, here, the issue is that we have spread this out. We've spread our state out here, which was the goal, but it's made it trickier. Because before, we could just put a bounds check on the depth of recursion. And we're trying to think about it that way, but that's just not correct. Like, I think this is just plainly incorrect now. But I don't know what that gets replaced with. See, I think it was you knocked us earlier with the link for the iterative flood fill. We need that, but something with like a restrictor that wasn't in place in a flood fill, right? Because I mean, like the problem we're hitting here essentially is like if we take this out, try it again. Yeah. Because like the problem here really is that we are succeeding at flood filling. Like that's this locking up, right? We're filling everything. I think we just need to figure out. Oh, for plus minus. What do you mean? What do you mean, Noctis? Absolute value of what? Wait, are you saying... Are you saying you think... these are not evaluating like I think they are? There's our flood fill. I don't think that's the problem. Because we do in fact want positive and negative, right? Because like, oops. Because what I'm doing here is, you know, to find the neighbor, it's relative to where we start. It's x minus 1 y, x plus 1 y, x y plus 1, and x y minus 1. So these negatives are correct, and I don't think we need the absolute value of anything. I still think we're just exiting at the wrong moment somehow. Okay, this is stupid, but I just want to see what shape this takes if we let it run for some high number. Wait, not that. That's wrong, of course. I just want to see what shape this takes. Well, this is interesting. So we've learned things. This is definitely wrong, but the thing we've learned is that this iterative thing is way the hell faster than the recursive solution. So that's good news. It means once we figure this out, it will have been the right move, because that was not known. It's still not obvious to me why it's deformed like this. It's because we remove a starting X value shift. What line are you looking at? Try it again, Suburgus? Sure. Yeah, we're still gonna OOM on that one, I think, Suburgus. The second iteration we lose original near one addition, so the grid shifts. Yeah, you're saying this guy, right? That this never gets actually added anywhere? Is that what you're saying? Because that's kind of what I've been thinking too. It's like we only find the neighbors and not the cell we looked at initially or something. What happens if we do this? I'm just curious. Did I fix it? What's our movement? Should be 7. Not seeing 7. What did that even do? Nothing good. Nothing good. I'm pulling up your paste spin here. Okay, so what are you saying? Add this. See if that makes sense. Yeah. Yeah, I think I understand what you're getting at. And it's possible we have to end up doing something like this because again, like with the recursive depth thing, tracking where we are is very easy. It's how many times did we call that function. With this though, this iterative approach, and this is the problem I think you're trying to solve here, we can't do that anymore. And we don't know how many cells we've added each pass through the loop. So we don't know how many... It's like we just don't know how many times we've iterated is sort of. Right, and you're just trying to count the cells that were added. Are we might be idiots though. Let me... For some reason I feel like I should be our top level iterator. Or something. Like I feel like we should be iterating across I and not cells or something. Do you know what I mean? Like I feel like somewhere we want to do just like this or something. But I don't know what that would actually signify. And then we'd do something in here. Because that would be like our recursion depth limit equivalent. I'm pulling up your link here. Let's see. Yeah, I don't think that does it for us. Maybe. I don't know. Yeah, I appreciate it. I might literally sleep on this one and just think it over a bit, because it's getting to be a little bit late, and I did have a full day of programming before I started this. So I'm kind of running out of steam here. Yeah, Noctis, that is interesting for sure. Yeah. That looks like a fairly significant change. Yeah. I'll tell you what. I think I will just call it there for the night, because I'm kind of mentally out of gas now. But yeah, I'll probably come back to this tomorrow. I feel like we're close. There's just something that isn't clicking here. But the good news is we have absolutely determined that when we get this working iteratively, the performance is going to be fine. So this isn't a wasted effort, it's just kind of a pain in the ass. But yeah, I guess I'll wrap up. I'll call it there. But yeah, as always, thanks again for the help and hanging out tonight, guys. We're getting there. Just gotta stare at this a little bit more. I'm sure we'll get it tomorrow night. Appreciate it. Yeah. Yeah, y'all have a good night. We'll see y'all next time.